That's fine too. And so we have this. Now let me see if I can make the sound as loud as it can get, which is probably none too loud. Let's see what this does. All right. So I don't know how to make any sound come out there. Let's see what's going on here. Is there a sound setting somewhere?
Hello, testing.
There doesn't appear to be. Sound volume. Yeah. Okay, there. Is there any way?
Hello, can you hear me?
I hear something. You hear something coming out of there?
Yes, that is me. Can you hear me, Mr. Sam?
Is that you, Abdullah?
That is me, good sir.
Aha. Well, the problem is you're not loud enough. Let me see if I can do anything about that. This can go up some. Try it now.
Hello, hello, testing, testing.
Oh, that's much better. Okay, good. All right. Then we're not going to start for about 10 or 14 minutes, 20 or 12 minutes here. Give you about 10 minutes to come in. So I'll transfer control over to you then. But the first thing I want to do is just talk a bit about the news. That's what I usually do.
Perfect.
Okay. And so let me clean up my screen a little. Good. Managed to make it louder than it was last time. That's good. All right. So this class is the 128 class, and tonight we have Abdullah, and next week we have another guest speaker. So there may be a last class may be about iOS. I'll have more information about them coming later. And there are more special events coming up. Beyond this, there's a competition this Saturday at 1 p.m., not 11. And then a speaker about Penguin next week. So, and then a job fair coming up on Monday the 29th. So those are things to know about. And the only other thing I wanted to do was talk about the news. Let's see if I can move that off the screen for now. All right. There. And so this one was pretty interesting, and perhaps that one. Oh, and I wanted to show you this project, which might be interesting. Let's see if I can get my other browser running. There it is. Okay, good. So yeah, here we go. This is the class I'm teaching right now in Saudi Arabia. And I added this class. I had an internal romance. Internal romance is the attack. It's the most important attack in 10 years, in my opinion, against Windows machines, because it was, in 2008 came MS-0867, and it would take over every Windows machine. And there was nothing like that again for 10 years until the tools were leaked out of the NSA, and that's what this stuff was. And that was Eternal Romance, part of the Eternal Blue suite. Now, the Eternal Blue is the name of the global suite of tools that became popular in common culture, but the Eternal Blue attack itself is pretty lousy. It crashes the machine half the time. Eternal Romance is the tool in this kit that really works. And so the project I wrote at that time for the 124 class used Metasploit, and you had to use a tool, you get a Metasploit shell and all that jazz. So I wanted to try that again, but now I'm updating it to Google Cloud Machines and Windows Server 2016. And the Google Cloud machines are fully updated because Google is not an idiot. They don't give you a default install. They give you an install with all the latest updates, which is what you should be using. So the first thing you have to do is roll back some of the patches because it's an exploit from 2017 and you have to roll back the patches that patch this particular problem. But even after you do that, there's a problem. It's vulnerable to this attack. And if there's a Metasploit attack built right in, and you can run the Metasploit attack and it will give you a Metasploit shell. So that's fine. And actually, now that I think about it, I'm sort of surprised that works because I don't know how they evaded Windows Defender. But when I try to do it manually, I can't evade Windows Defender. So this is one way to do it, but if you're going to get the OSCP certification, you have to get above this. The problem with Metasploit is it does everything for you, and you don't even need to know what you're doing. All you do is set the IP address and run the exploit, you get a shell, and that's nice if you're just trying to get in, but if you're trying to get your OSCP certification, or if you're trying to be a real pen tester in the real world, that is not good enough, because it took about 1.5 years for this Metasploit module to be written, and it always does take forever. So by the time anything's in Metasploit, it's so old as to not be worth much. You really have to learn how to use new attacks. And the new attacks are never in this nice, tidy format. Somebody publishes a proof of concept in whatever language they like Python or C or something, and it just does one thing, and you have to customize it and work with it. So to do this without Metasploit, you get the original Eternal Romance exploit, and this thing was a proof of concept. You give it a name and password for a SMB share, like the guest account, and when you run it, it creates a file called cpwned. Now, what it's actually doing is creating a system. It's exploiting a listening service, and it's using some kind of memory corruption in this listening service, and it gets to run code as system as a service on the Windows machine. And that turned out to be a huge problem. It's taken me the last 3 days of struggle to get over it, because you can't just execute arbitrary commands as a service. Most commands don't work at all. Because you're not logged into an interactive command shell, and almost everything you try to do that you want to do, like ipconfig and task lists and stuff like that, doesn't work. So I couldn't. So I saw this. You can make a file called cpwned in the root. That proves you have system privileges on the machine. So you need not like to do things, but most commands won't work. And so what I used to do is I do the typical thing most people do, is get Metasploit up there. So here you can run a command, you can copy a file on the server, and so then you can just make a shell and send it up. So I tried that. I created a shell code with MSF Venom, same way we usually do, and I send it up, and it totally doesn't run because Windows Defender stops it. Now, I couldn't turn off Windows Defender, but that is like super lame, and I'm hoping to find something that can at least penetrate Windows Defender, and probably real antivirus too. So I then made PS1 encode, which is related to the PowerShell Empire, a later version of the thing. This is one of the many things you do to make PowerShell code that is scrambled up and is supposed to go past antivirus, but it doesn't anymore either. And what you're doing here is kind of a mug's game. I mean, every time any AV evasion tool gets published, they update Windows Defender and everything to block it. So anything you can find is blocked. So the only thing that's going to get through is things that are not known. And I don't know, it seems to me like if I was paying for a pen test, I would not want them to tell me they have 0 days and they get in. I say, well, there's nothing I can do about that. So this is not really fair to be part of your pen test. So I'm not even sure it would make sense. So I said, so I'm switched to the really modern technique. This is what I've heard about in the last year in instant response all the time. They say the bad guys are giving up this nonsense of using malware. Malware is for the birds because it gets caught. You do living off the land. Can you get whatever you're trying to do done without malware? Just use the built-in commands where you won't get caught. And I was able to do this. It took me about 3 days to do it because I kept trying to run a batch file as a service and it totally won't run right. And I kept trying to run interesting commands as a service. And it finally occurred to me, I don't need to do that. All I need to do is create an administrator user. And that command works. NetUser Waldo password add. So now I can create a user. I can use this exploit to create the user, and I can use this exploit to promote that user to a local administrator. And now I have an SMB share and an administrator password. And you can now just execute commands directly through that. And the tool you do that with is SMB exec. And you have to install a bunch of dependencies and compile this junk from Impacket. And now you have AT exec, one version of this. This will execute something through an SMB service, and you need an administrator name and password, and then you just now you can execute commands like systeminfo, netuser to enumerate all the users, netstat -an to enumerate the connections, and you can do task list all the tasks. You can now execute commands one by one and get the results. Yeah.
You have to roll back, right?
I had to roll back the patches, yeah.
Patches.
If it's been patched after about March of 2017, this attack won't work anymore.
This for my curiosity.
Yeah.
You roll back, let's say you get access to a server and you roll back the patches.
Oh.
You make an account, and then you reapply the patches. Do you still have access?
Well, I think so. Now, of course, I wouldn't roll it back in a real attack. I just rolled it back so we can use this attack. But if you putting off patches and taking off patches and putting it back on is not supposed to affect accounts. I didn't roll the whole system back. I just took off the patch. So that should not affect any configuration issues like counts. Anyway, so I thought I'd show you that. I was happy to get it working. Although now that it's over, it occurs to me that Metasploit must have done something in their built-in module that successfully evaded Windows Defender, and I don't know what that is. So, you know, somebody who's better at evading antivirus might have a smarter solution. Anyway, but I thought it's interesting to see how to do it. And I learned a lot about Windows services trying to do it. So Facebook is, or Twitter is going to do something to try to see, the US Congress is very, very, very angry about election interference, and they're going to punish our media companies. So both of them are really getting worried about it. Twitter is now publishing, they're going to do something to stop tweets that lie about how to vote. And other people, like there was a bunch of tweets that came out that told people Democrats could vote by text or something just to make them waste time or give them the wrong time to go to the polling place. So they're going to supposedly try to stop that. And Facebook is cutting their profit in half and taking half of their annual profit and setting it aside for fines because they're anticipating a huge fine from the FTC for privacy violations. And I must say, Facebook totally deserves privacy violation abuse. They have been ridiculous about invading everyone's privacy and violating court orders. They've been just begging for this for years. So I think they're going to get hurt. Yeah. Anyway, all right. And let's see if there's anything else worth mentioning on the news front. What's that? The lab day? Something about the lab? I can't hear you.
The Metasploit thing.
Yeah, what about it?
What is that? The challenge, the competition project?
It's not a project anywhere here yet. I might. There's a version of it in 124, but it does against 2012. Anyway, so there's a on Ethereum. There's a this same attack happened in on Bitcoin a long time ago. In Bitcoin, they attacked memory wallets, where if you use a common password, they can find your private key and steal your Bitcoins. And I saw that done live at Hope. A guy would put in an account, and within a few seconds, somebody would steal it. The same thing's happening on Ethereum. It turns out with Ethereum wallets, you can actually have a private key of 1 or 2 or 3. It's supposed to be a 256-bit random number, but you can use really small numbers. And if you do, of course, you have bots running that will totally steal your stuff. Anyway, so he found a bunch of these, and he's trying like the several billion common keys, and of course the money gets stolen right away. So there is somebody stealing them, account that is stealing them, where it's piled up like $50 million worth of Ethereum. It's just sitting there. Nobody's cashed out yet. So somebody's running a bot, blockchain, stealing all the stuff they can find. Oh, that's one of the students online, isn't it? That's what that must be. I was trying to figure out who's coughing so much. It must be a student online. All right. Anyway, so let me see if I can hand this over to you. I think what I have to do is stop sharing my desktop. So you can. Let's see. You share? Yeah. How do you?
All right.
I'd like to let you share your desktop, but I don't know how to do that. I have to unshare.
Yes, because it tells me here that I can't share while other participants are sharing. So.
Yes. So says it stop share here? I guess so. There. Can you share now?
Let me try.
I have no idea what that nonsense is. Aha. Looks like something is working. Oh, good.
Can people see me?
Yes. We can see your desktop. And
Hello.
no, Josh, that's right. It'll get bigger. That's just a picture of a Zoom client. All right, great. It's working.
All right. Let me see if I can present. Perfect. All right. So thank you so much, Mr. Bone, for the news crunch. When I was taking CNIT 127, I was always anticipating the tech news segment that you do in the beginning of the lecture. It was really cool. So,
oh, I didn't know you were in that.
I took CNIT 127, 124, and 123, and I'm going to roll to 126 next semester. So. Oh,
that's great. Well, I'm glad to have you along, and you should introduce yourself. I don't know enough about you two. You should tell us something about you.
Of course. So, hi, my name is Abdullah Joseph. I work as a mobile security team lead at a company in Germany called Adjust. So what we do is mobile attribution providing. So advertisers would come to us and they would install our SDK, which we would use to track their attribution, whether the installs that happened actually were legitimate, and which network brought them forth, brought the users forth. And yeah, that's basically what the company does. I'm happy to say we're second in the largest share in the market. The biggest one is a company in the US, but we're taking over more or less entirety of EU. And we do see around 25 petabytes of data per 25 days. So we're more or less a pretty big data company. And since I actually graduated in a degree in game design, so nothing to do with security at all. I worked as a software engineer for most of my career, mobile development specifically. And in the last around 3 years, I was working as a fraud specialist. So more or less trying to find ways to make sure the installs and the clicks that come to our servers are actually coming from incentivized real users and not from bots or emulators or something like that. And just recently, I'm happy that the CTO thought I was doing something useful in my weekends, and I got promoted to team lead, and I'm forming a new team in the company. So yeah, that's a little bit about me. Originally, I come from Syria. I spent most of my life in Malaysia and in United Arab Emirates. And right now, and for the last 3 years, I've been living in Germany. So that's that. And there's a couple of certifications in here I made lovingly paid for by my company from GIAC Association. They are pretty great. I highly recommend them if you guys if you get into a company that is happily will provide you the training. And that's about me, I guess. So what is the lectures? Let me get my notes in already. So what's today's lecture about? I'm basically there is this lovely malware that malware campaign that took over not too long ago, around March, I believe. Most of the research, the actual research came out from it. And it's basically supposed to be a pretty big adware that infects your mobile application and uses the legitimate Android API to basically launch clicks and installs and install apps on your behalf and try to get advertising data from you. So basically, what an adware does on a mobile device is that it will just quick disclaimer, I can't really see any of you in here, so if there is a question, please stop me immediately and somebody can just speak and interrupt me and I'll answer to it. The lecture is supposed to take around 40 minutes, 35 minutes, and so there is a Q&A afterwards, so you guys can let me know if there's any questions then. So back to SimBad. I didn't come up with the name, Checkpoint did. The folks in here. So the idea of Android adware is that it will install itself as an app, as a legitimate app. And what it would do is that it will collect legitimate advertising data, basically the same amount of device data that we collect at Just SDK and every single attribution provider. This is legitimate device data. It's very much e-privacy compliant, GDPR compliant. The malware would basically collect it, send it over to their servers, and make it that that user has launched a click, an advertisement click, through to our servers, and it would say, yo, this is a legitimate user launching a legitimate click. Here's the install information. Attribute my network the install of this user. So basically, the malware would be running usually what's called a C2 server, a command and control server, that would do all of this stuff automatically, and they would get a lot of money from it. So basically, imagine, I believe at one point, Angry Birds traffic, so that basically any advertisement displayed on any Angry Birds game would cost advertisers around $10 per install. That means that if a user came from seeing an Angry Bird an advertisement in an Angry Bird game, and he clicked on any advertisement, something related to booking.com, the advertiser in there would get $10. That's a lot of money. And if you try to automate that and you put it into 200 apps, you can retire pretty early. So this is what this campaign would do. Usually, most of the Android AdWords that we've seen do something like this. So let me backtrack a little bit in here. I kind of skipped forward the reversing methodology. I'm going to get to it right now. And we have the analysis part and the findings part. So part of my job is to try to analyze this adware to understand its behavior, try to see if we can make anything in our security products to prevent this thing from happening, or at least understand how the attack looks like so that we can prevent it either client side or backend side. So the reversing methodology. This is not something I came up with. This is something I was taught at one of the certifications I got. It's called GRIM, the name of the certification, Reverse Engineering Malware. And it's a very, very amazing course. And this is one of the main techniques that we were taught, how to think in terms of analysis, how to approach a sample, and how to actually abstract away the tools, and because the tools will change depending on the platform. And basically try to have some sort of a loop that can involve reporting so that you can, at the end, be able to present something useful in the terms of a story. You kind of have to make it into a story. So this is the idea behind it. The first one is artifact collection. You need to know what you're dealing with. So if it's a Windows malware, it's going to be most probably a PE file. PE is the extension for the binary files that run on Windows machines. If it's an Android application, it's usually going to be what's called an APK. APK, if you've been following along with Mr. Bones' class, is an app. It's an installable app. An app can be compiled, zipped into an APK format. And this is how you can download, distribute, and share apps. If it's Linux malware, it's usually going to be an ELF binary. If it's a JavaScript one, it's just going to be a JavaScript script. So you need to know what you're dealing with, because based on it, you would be able to derive some information. And so, for example, we're going to see now in an Android APK, there are very, very, very clear things that the app must announce to the system so that it can conduct itself in the Android ecosystem. Same thing goes for iOS. Quick disclaimer: there's a lot of times I see that the iOS malware and stuff like that don't get too much love. That's not because iOS is harder to reverse. I believe if you follow a good methodology, you can reverse iOS apps as good as Android apps. And the thing is, with iOS, it's a little bit harder to distribute the malware because usually Apple signs everything with an Apple App Store certificate so that only your iOS device can install anything. If you have a jailbroken device, all bets are off. You can get any IPA, which is the format for the files, and you can install it. However, if you have a jailbroken phone, like usually Apple doesn't take too much responsibility, so they don't pay too much attention to it. At least that's just my 2 cents. So the idea behind it, the methodology, basically collect some artifacts in here and then do some sort of an analysis, either static, dynamic, whatever you want to call it. I believe some folks also call it behavioral analysis. Different books say it differently. Basically, report any findings that you have into some sort of a summary, and then come and do the same thing all over again until you can answer some questions. Why do we need this step? Because I worked on samples that took me around 2 weeks to finish the entire analysis stage. The samples were very rampant. Sometimes they would change their own code. It wasn't fun. So I assure you, if you do some analysis, which is what most books focus on, but you forget this part, it's going to be a very annoying morning where you try to catch up onto what you did last weekend. and it's not fun. So usually this is the circle that I follow. And we're going to see right now how this methodology would work in practice using this SimBad campaign. So we've already talked about this. Quite a lot of big tech journals ran very happy with it, especially TechCrunch. This actually was shared at, through our company's internal channels, and everybody was so scared of it and thought that they want some sort of an antivirus on their phone to get rid of it. Just to tell you, most antiviruses on your phone would do worse than what SimBad would do, so please don't do that. There's something called Google Bouncer, which is it's an analysis tool that Google runs every time an app is uploaded on the Google Play Store. It's not as bad as everybody thinks. It's actually pretty good. It has very good patterns to match for known malware samples and things like that. If there is something new, it's usually labeled into a campaign, and Google is very quick to react as soon as they get any sort of research on it. So just my 2 cents, never install something like antivirus or anti-malware or something like that on your phone. So pre-analysis. This step, we kind of need to do it because it really depends on what you want to achieve with the sample. The sample is a binary. It's a library. It has instructions and bytes. Those bytes are by nature not malicious, but you kind of need to know what exactly you need with it. If you combine those bytes into specific patterns, they might do something that you're not very happy with. That's what usually people call malwares. Malwares are something that does, it's bytes that do something that somebody might not like. In this case, the creators of SimBad really would have no problem of propagating their malware as far as the seas could go. However, the user might have a problem with an app that installs other apps on the device. If you've ever worked with Windows, I assure you that's the biggest malware that you can ever get in your system. Windows 10 keeps installing stuff on my system like there is no tomorrow. So you can categorize that as malware behavior. So the first step that you need to know is, why are you doing this analysis? In my case, because we needed to prove, we needed to understand the behavior of this malware. How does it do it? What's the actual technical bits that it's doing to do this stuff, so that we can protect it against, we can include those behaviors into our SDK, and we can be able to mitigate it. Just telling you, SDK stands for Software Development Kit. It's basically a library that we give to clients, and clients in this case are other apps. So for example, Spotify is one of our biggest clients. They have our SDK in there, and they use it for attributing their advertisements. The clients in this case are not the users of the device. We actually have clients a little bit will work as B2B, business to business. So clients, as I said, in this case, are big app development companies. And we don't want them to go to another competitor. So that's why we try to be as security conscious as possible. In our case for SimBad, the pre-analysis phase is that we've received information that this malware, this library campaign was able to do those 3 things. We need to prove if this is correct or not. So the premise I'm working on right now is guilty until proven innocent. That's not always the case. If we go into most automated analyzers for mail filters, they work on the completely different side, innocent until proven guilty. So for example, if you have if you work in a very large organization, something like I don't know, eBay, Facebook or something, they would have automated tools, and they would have an entire security team dedicated to handling mail attachments and mail delivery systems. So in that case, they would treat any attachment that comes, well, they need to prove it's doing something malicious. We're working on the opposite way in here. We need to prove, we already know it's malicious. We need to prove how. So when to stop, in my case, is whenever the following functionalities has been discovered. This could be different in different cases. So that's something that you need to establish, because if you enter a loop like this, it'll be very hard to get out of it until you know exactly why you need to get out of it. So let's go for the analysis part. The artifact collection. The more you know about the file that you're analyzing, the better this stage the more fruitful stage will be. If you know nothing about Android applications, it will be pretty hard for you to understand what sort of analysis tools can you do with it. I heard that if you run man-in-the-middle attack on any Android application, you'd be able to understand everything in it. That's not true, because there's a lot of things that the environment that you're executing in would be different, and you have to be able to interact with it. So for our artifact collection stage, what we'll do is try to focus on those three things: functionalities, permissions, and long-running tasks. In the case of, there's also entry points that we're going to focus on. Android applications have more than one entry point. The usual one, which is, if you've worked with C or C-like languages, which is basically the main function, that's the front door. However, Android applications can execute things through side doors, which is what is called in the Android lingo broadcast receivers. So basically, it's reacting based on a user or a system broadcast. And the app could be completely dead. You've never opened it, and a broadcast receiver would still execute functionalities as side doors, usually without you ever knowing it, because there is usually no UI related to it. So Android applications are rampant for doing this. iOS is the same. Then we have services, long-running tasks. Usually, legally speaking, they would do something like synchronize databases and try to make sure that everything is up to date from client side and backend side. However, for malwares, they usually use services as a way to wait when the user does something so that it can react upon it. And since it's a long-running task, Android system is very good at optimizing this. This service, any service, could run for days on end, and it wouldn't affect the performance of the system, depending on how intensive it is. And yes, it's a little bit hard for me to hear. Is somebody speaking?
No, somebody's just noisy walking by in the hallway.
Wow, you got an amazing microphone there.
I guess so, yeah.
All right. So to continue on, the first thing that we need to do is to recover most of everything in here. You'd need to do what you'd need to do is dump something called the Android manifest.xml file, and the manifest is a file. It's an XML file, usually encoded, but with tools like apktool, you can decode it. And what the Android manifest does is basically a declaration from, it's a contract from the app to the operating system. It's telling it everything that it is allowed to do and everything that it would do in this operating system. You enter into a house, into a hotel, and you're a stranger in there. You've never been to that hotel. You're the app, and the hotel is the operating system. You would tell the hotel basically how long you're staying, for how many people are with you, if you need room service or not, are you going to take breakfast, stuff like that. You would tell it everything that it needs to know about your conduct in the operating system. And there is no way for a malware to be able to hide from this. If it's running a service, it would clearly must state that it's running a service. You can't hide from this, from the operating system. So that's actually a very big advantage to Windows analysis. For example, Windows analysis, literally anything can run without any sort of contract between it. I'm not a Windows person, so please pardon me if I say this out of ignorance, but I do believe there is some way that you can sign your own app so that you can make sure it's coming from Microsoft. I know you can sign drivers. I don't know about binaries. So yeah, I could be mistaken about that. But for Android applications, you need to be very crystal clear about what you need to do. Throughout the slides will be given. I will see if I can share it either with Mr. Bone helping me share it on the website, or I can share it on the GitHub repo at the end. There is apktool in here, and anything highlighted in this beautiful red is basically a tool that you can download. Usually, it's not hard to download any of those tools. This is, for example, Java applet that you can download easily. And as soon as you download it, you can run the following command on your APK file, which is the app. In this example, there's a lot of apps that operate that have SimBad in it, but one I was able to get that was relatively easy to reverse. It's called count.deleted.photo.recovery. What it does is a photo recovery app. If you deleted your photo, it can recover it. I actually deleted actual photos and tried to use this app. It's not recovering anything. So please never ever install anything related to, I don't know, a flashlight app or cleanup app or memory management app. That shit doesn't work. So never ever try to install it. It's just malware all through and through. So if you run this command on it, you would be able to get the Android manifest file right here, decoded in human readable format. Now I have to warn you that Android manifest file is pretty big usually for any production app. However, there are some tags in here that we would go over, and you would be able to see it and understand what it does. So for example, in here, there is a tag called uses permission. This one is documented in developer.android.com. It's basically the MSDN of Windows. The developer.android.com. It contains the entire Android ecosystem API, every single functionality in there. So you can go to that website and you would be able to get an answer to anything related to Android ecosystem. Uses permission is basically what the app tells the operating system that they're allowed to do. That's what they want to do in the Android ecosystem. So for example, our app in here wants to have access to read access to external storage. It also wants to write to external storage. All of those are basically what access to device data comes from. It wants to access course location. It wants to know fine location. It wants to know exactly your GPS coordinates. That's not too upsetting because actually most advertisement SDKs usually ask the developer to put this in there. They would like to know your GPS location so that they would have some fraud prevention metrics in there. If suddenly you have a new app that came and you paid advertisers a lot of money to market this app, and basically you get, I don't know, 3 million installs from China at the first day, you would have a small incentive to know that are those installs actually legitimate or not. You can use IP addresses, however, Tor and a lot of other things, you can, and with VPNs, you can jump around quite a bit. However, this checks our client side. That's why a lot of advertisers love it. For example, our SDK uses access network state and access Wi-Fi state. It requires to know what sort of network you're running on. So, and there is another one called called receive boot completed. Basically, this one happens as a broadcast. It's a system broadcast that gets launched to every single app, and any app that has this permission is able to do something with it. It happens when the device boots up for the first time. So you turn off your phone, you have that app installed, and you boot it up. This basically, there will be what's called broadcast that will be fired, and your app can listen to this broadcast and it can react upon it. That's where the side door concept comes from. So to summarize, this app has the following capabilities. It can store data and write data to the device. It can collect device data and perform actions when the device boots up. Moving forward, we have multiple entry points in here. The first one is what's called the main activity. This is the front door. You can't get away from this one. It's basically the screen that pops up when you first go to your app menu, and then you press on the app. That's the screen that pops up. You can't get away from this one. You must have a front door. There is 3 side doors that I was able to detect, and they're all coming from this package called com.rxdroider, and they do different things. The first one is what's called a receiver. It's a side door that doesn't react to anything. So that's a little bit weird. It's a side door that doesn't have a key. We can investigate this one a little bit further. Then there is a second entry point that happens when this broadcast comes in. User present broadcast happens when the user has unlocked their phone. When you, if your phone is turned off, it's on, not turned off, if it's on standby mode, this broadcast won't happen. Once the screen actually turns on and you input your password, your lock screen password, this broadcast is fired to every single app. And if there is a listener to it, any app can do something and react upon it. That's completely legal in the Android ecosystem, by the way. There is nothing malicious in this manifest file that any other app is not already using. For example, Telegram has user present broadcast. It uses it to sync the databases. So there is nothing in here that is illegal, technically speaking. And there's this thing called, it's a third entry point that I was able to detect. It's invoked by server commands. It's called port receiver from the same package name. And parse, it gets invoked when those broadcasts happen. We're going to take a look at what parse is in a minute. If you actually just Google com.parse.push, you're going to find that it's mobile backend as a service. It's basically a backend software that comes pre-packaged to receive and interact with mobile applications. We're going to take a look at every single one of those in detail in a minute. Just saying, how am I doing on time, Mr. Bone? When is a hard deadline for when we can stop?
Oh, well, yeah, it's already about 40 minutes in, so we should stop in like the next 20 minutes or 30 minutes.
Okay, that's good. That's good. I think we're doing good time in here.
Okay.
So we got a service that was detected. So in here, there's this thing called OverService. It's a long-running task running in the background. In this phase, it's a little bit hard to understand what the service is doing. We just know that it's doing something. And we have lots and lots of third-party libraries. There's, I believe I read this on developer.android.com or some blog. They ran a statistic. 65% of an Android application is not the developer's code. So it's usually third-party libraries that do networking, that do image processing, advertisements, a lot of stuff. So you will see a lot of package names that has nothing to do with the actual application. And in here, the ones that I was able to collect are those 6. And how do you know if an application, if a service or an activity is part of the application or not? That's easy. If it has the package name of the app, which is this in our case, it's related usually to the app. If it's anything else, it's usually not. I say usually because there's exceptions everywhere. So for example, if we want to understand what third-party libraries are those, you can just Google them. Tapjoy is an advertisement SDK. Startup is another monetization SDK. Parse is a mobile backend SDK. And we have a couple of marketing SDKs. This is one of our competitors, actually. And then we have this thing, RxDroider. We've seen it a couple of times. It has 3 side doors, and there is no legitimate website on it, and Google says it is SimBad. Now, this is not so smart because usually if you're doing this analysis, you might be the first person to do it, so you might not always find something like this. However, you can investigate those libraries, and if you see that there is, I don't know, they have Spotify on their landing page, they look legitimate, they have a LinkedIn page, they would be a little bit more legitimate than something like this. RxDroider immediately showed me nothing, no websites, no nothing. Again, I could be biased because I did this analysis after Checkpoint and after Google already shut them down. But it would have been interesting to know how this, if they honestly had a legitimate website or not. So, and this is the findings that we have. Just reiterating them over here. The app uses a lot of third-party libraries, possibly malicious RX Troider. It can react to user-present system broadcast, and we detected that it is invocable by backend. There is entry points that are invocable by backend. Could it be that it's a C2 server? We'll need to know that at the dynamic analysis stage. So, which brings us forward to dynamic analysis. This stage basically is black box testing. You will monitor some changes in the network, some changes in the files, and basically see the ins and outs under different environments. If you're on the app on an emulator, will it react the same if you're on it on a physical device? And basically just do compare and contrast on the results. So the environment that I had when I ran it was a rooted Android emulator, and I had some network monitoring and file monitoring, and I'll get to each one of those in a minute. So the emulator that I used is called Genie Motion. There is a commercial version and there is a free version. The free version does pretty much everything that the commercial version does, so you can go ahead and download it for free. It's very easy to set up and tear down, gives you root access by default, and since it gives you root access by default, you are allowed to run scripts on it as root, which is amazing because you can install system-level certificates. You can install what's called BusyBox. BusyBox, for embedded developers, they use it a lot to install some basic Unix tools. So find, cat, ls, what is it called? Who am I? Any Unix command that you've seen is not always the same on different platforms. So for example, for Android, the find command in there is actually much different than the traditional GNU find that you would find on a Unix system. So BusyBox allows you to have basically the same tools that you interact with on a Linux system on any embedded device, including emulators. Right, so moving forward. I'm just going to explain what is the difference between HTTP and HTTPS in here. I don't know if many of you know the difference, but basically HTTPS is encrypted, HTTP is not. So I think most of everything related to mobile communication right now, at least I like to believe so, has moved on to HTTPS, the encrypted version. However, if you try to run a proxy and sniff the traffic in between, you will get nothing. You will get garbage. So to mitigate that, you would have to deem your proxy as trustworthy. To do that, you have to install system-level certificates. Or you can install user-level certificates. But system-level certificates, I believe, work a lot better. So if you have root access to the device, you can do that. And there is this lovely script that I have in here that does this. All the scripts, by the way, will be shared. They are already up on a GitHub repo. I will share the link afterwards. And if you have any comments on it, I would love it if, or modifications, I would love it if you can do the open sourcey thing and make an issue on it on GitHub or a pull request, which is better, to fix my crappy Unix scripting. And yeah. So I have a quick slide in here about what's the difference between an emulator and a physical device. First of all, don't run malware on your phones. That's not so nice, especially for analysis purposes. But if you try to do something like that and purchase a rooted phone, you would have the advantage of being able to run ARM-only native libraries, as opposed to an emulator, which can only run x86 instructions. So if you want to label it like this, which is a bad label, but you can go for emulators only run x86 and physicals only run ARM instructions. There is overlap. There are ARM emulators. However, if you've ever tried to do some honest-to-God analysis on an ARM emulator while you're running an x86 host, which is usually what every single computer or laptop on the market is, you would find it tremendously slow. So I would highly suggest, for the sake of analysis, that you run physical. If you have ARM-only native libraries, just stick to physical. For anything else, you can go for emulators. There is this beautiful software that I like to use. It's called Mitim Proxy, and it is terminal-based proxy. You can use burp if you'd like, and basically any proxy that can work as a transparent proxy and can sit in the middle between your client's communication and the internet, and so on goes back and forth. If you can do that and basically be able to see the traffic, that's amazing. And you can use any tool to do that. So for file monitoring, I would like to know that what are the files that changed when I run an Android application? What's the stuff that happens before and after? On Windows, we have those two beautiful tools called Procmon and Rickshot. Those are amazing. I love them. They are the best tools in the world. However, there's nothing like that in Android. Those tools allow you to see exactly what changed when you between 2 points in time on the system. However, on Android, there is no such thing. So I hacked away a small script using find and Unix commands that tries to do the same thing as what the Rickshot does. You run it first time, and it takes a shot. And basically, you would run the app. You would do all the analysis that you want, and then you take another shot, and it would basically print a delta of the files that changed. And I'm working on a version that would actually dump all the files for you and tell you exactly what changed, but that's hopefully in the future. So while we have our tools ready, we run the app, and we see that it actually has a lot of GET and POST requests to this server called Adroider, and nothing else. There is zero communication happening apart from advertisement SDKs. So advertisements coming up to the screen, they would need to do some networking. Apart from those, there is nothing happening. There is no backend except for this one. We see a lot of GET and POST requests happening in here. The last one actually does stand out. It looks like this. I don't, to my simple eyes, I couldn't detect anything malicious on this one. There is no, I don't know, secret password API or a command called destroy everything. I couldn't find any of those in here. So I'm just going to store it into memory and see if I can move forward with it. For file monitoring, we were able to find a lot of cookies. And if you've ever worked on an Android application, you would know that it uses what's called web views to display cookies, which is basically kind of like iframe for HTTP for HTML. It's a super small window that runs JavaScript, and it has a lot of cookies. You can see it in here: web view, web view, web view. There's some stuff relating to Crashlytics, which is crash detection SDK. As I told you, there's a lot of libraries that has nothing to do with developer code in an Android application. It really was hard for me to see anything that stood out on those things. I didn't see any weirdnesses happening, no encrypted bits, no secrets, no commands, nothing like that. So unfortunately, dynamic analysis was not very fruitful. Mostly, I would attribute this fact to that I did the analysis on a server that was already abandoned. The server is running. However, I don't think there is anybody behind it. The analysis that I've done was after Checkpoint already did everything that they could and communicated with Google to shut down everything related to this campaign. So you kind of enter the dynamic analysis stage already knowing that you can lose this one. However, you have to do it just to know if there is any weirdnesses that are already happening on apps that are on an APK that you were able to get. And luckily for us, Adroider.com is still live. As far as I checked, it's still live now. So if you're taking Mr. Bones' advanced penetration testing course, you can just go ahead and do some nasty stuff in there. All right, so the next step, static analysis, and this will be the step before the final one. This was actually a lot easier than I thought. The way I usually approach static analysis is basically check the entry points at the beginning. and try to report anything that you can find. And basically that's it. Go through the entry points, and you don't have to analyze every single file or every single function. Just try to understand what the entry points are doing. And from there, you can more or less map out a journey on how the app should behave when something happens, when it reacts to a system broadcast. So this is the previous slide. We have 4 entry points. The first one I'm going to actually go through is the side door, launch receiver. So, sorry, I am blind. I went through UnlockReceiver. So the second one, pardon me for that. So the user present, what happens when UnlockReceiver actually gets invoked? And we know from the manifest that UnlockReceiver gets invoked when the user opens their app and enters the password. Opens their device and enters the password to their lock screen. So what does happen there? The file was pretty small. I think it had only 3 functions. And if you look into one of those functions, just telling you, the functions are all obfuscated. So the first step as a good analyst, you have to rename the functions. So if you see something and you were able to analyze it properly, you would have to rename it. For example, I use this convention, which is CCC, for something that I kind of know how it's working, CC for something that maybe I spent some time on it, and C underscore for something that I've definitely spent a lot of time on. I know exactly what this function is doing. In the future, when I review my analysis, just by looking at the name of the function, I would be able to discern what exactly it's doing. And just by looking at the small prefix, I would be able to know how much time did I spend on it. And I have this small convention that I use with the exact keyword and the exact way of putting it, and just trying to use it so that in the future, when I'm done with the analysis entirely, I can run a small script that would basically grip every single thing from here up to the end of the function, and I can use that in my report when I'm submitting it to my superiors or when I'm publishing it on the internet. You can use that, and it's going to save you a lot of time. So I would suggest stick to a nice convention when you're reversing stuff. And what this function is doing is basically running OverService. That's the entire thing of what it's doing. It's waiting for a small time delay, and then it will run OverService, which is a long-running service, as we talked about before. We don't know what it's doing, OverService. We're going to figure it out in the next couple of slides. And what we see in here is a small analysis of OverService. Again, it didn't have too many functions. I tried to rename it and understand what it's doing, and it's doing a lot of weird stuff in here, but the 2 most important lines that should stand out is this one and this one. Market : / is the scheme used to run and launch Google Play store pages. So if you run on your browser now, market : / com.facebook.katana, you would launch the Google Play store page for Facebook, the Facebook application. And that's basically how what's called deep linking works. Deep linking is basically a way that you can prefix : / with an app schema, and you would then put in here whatever it is, the package name that you want, and it would launch it for you based on what the app does. 9apps is an Indian contender for Google Play. It's a marketplace for usually operated in the region of India. And basically, if you put in here 9apps : com.spotify, you would be able to get, and if you have 9 apps installed, you would see the page for 9 apps. So this long-running service, what it's doing is that it's taking commands from backend, and based on the commands, it would pop up while you're working, while you're on your phone, checking Twitter. It would pop up a store page for whatever app that the backend would give it. Unfortunately, we can't prove the list of apps that are part of this campaign because the backend is more or less dead. It's been abandoned. So as you can see, as you saw before from the GET requests, we couldn't really get any app names in here. So moving forward, we were able to, right now we know that OverService is capable of launching store pages. And if we scroll a little bit down, we will be able to see this function. What this 4 lines of code do is that if you give it a file of type java.io.file and you supply it with these parameters, it will install an APK file for you in the device without user permission. That's completely legal in the Android ecosystem. If you go ahead right now and make an Android application and you put those 4 lines in it and you replace from file with a downloaded APK, you would be able to install it without user permissions. And if you've ever seen on Google Play, if you install Firefox or whatever app, it will show a small dialogue that tells you what this app is capable of doing and do you agree to it. So for example, Firefox would require usage of internet, and it might require usage for your camera or your microphone, and you agree to it. That's okay. However, with those 4 lines of code, you basically preemptively agree on anything. So there is no permission screen that pops up if you put it like this. And we just figured out that this app, this RX Droider campaign, is capable of installing local APKs on your device without your permission. So this is the findings that we came up with. I'm going to skip forward on this one just because I'm just repeating myself on this. And we were able to answer 2 out of 3 questions. Can the malware download and install APKs without user permission? Yes. Can the malware launch Google Play and 9 app store pages? Correct. However, we didn't answer the first question. Can the malware hide itself from launcher? Can the app actually hide itself entirely so that the main entry point is invisible? You will not be able to see it. Therefore, without a computer, you would not be able to delete it. Can we say that claim? That's what the claim that we need to answer. Sorry, that's what the question we need to answer. Is it possible to do so? And I'm just basically trying the second door right now. The second side door I tried is port receiver. And without even looking too long, because usually receivers, broadcast receivers, don't have too much code. The first 3 lines of code that I found on this function is a function I renamed into hide app. And it's capable of running set component enabled setting. And if you run set component enabled setting with flag number 2, and afterwards with flag number 1, and you look at developer.android.com, you can see that flag number 2 talks for component enabled state disabled. You're basically disabling the main front door. And the second flag in here, that 1, corresponds to don't kill app. So what this line does is basically tell the Android ecosystem, please disable my app to be used. However, don't kill it. If it's running, don't kill it. If it's running and you would be able to get services and get system broadcasts from it, please don't kill it. And then we run this line to basically re-enable the key guard. In simple lingo, this basically refreshes the app menu. So what those 3 lines do is basically hide your app and refresh it so that you would never be able to uninstall it unless you hook it up to your own computer and run ADB uninstall or something. And that's basically it for the analysis. We were able to answer all 3 questions, mainly not in the dynamic analysis stage, but in the static analysis stage. And how did we do that? The static analysis is that we went through doors. We went through side door number 1. We went through a small depth of 1 through it. We followed along from UnlockReceiver to OverService. And we didn't go too far down the rabbit hole in this one. And then we went forward to port receiver, which is the second side door. And the decompilation in here was done using a tool called JADEX, JADEX. And with that, I believe I should have had a slide in here that shows how to work with JADEX. It's actually a super simple solution. I will upload this presentation with the added usage of JADEX to the GitHub repo, which I have hosted at the end of the slides, so that you guys can see if you want to recreate the same environment. And that's pretty much it. And as I said before about reporting stage, I just have one slide on this one. If you follow a nice convention of something like / ***, a keyword, and then you go ahead and, like for example, in here, I like to write a small summary of the function, and in here, any side points. And if you have such a thing, you can use Unix tools to basically have a small dump of all the analysis stages that you did, every function that you've spent time to reverse, and be able to put this into a text file or a Microsoft document and present it later. I find this tremendously helpful just because usually if you spend a lot of time on reversing, you don't want to go ahead and reread the code. You want to reread the summary. As we said before, you want to create a story. And to be able to create a nice story, you kind of need to use a language that humans understand, not Java. So that's that. And that's basically it. Please pardon me if this became too technical at one point. The entire idea of it is that you'd follow a small methodology, a methodology that looks more or less like this. At least that's the one that has been working for me for a good amount of time. You try to go from very low resolution, artifact collection, what this app is capable of doing. You go from medium resolution with dynamic analysis, basically black box testing. And then finally, you would go dive into the code with your choice of decompiler or disassembler. Try to go at it from top to down. And that's a nice methodology that you can apply for iOS as well as Android and as well as Windows. I don't see any difference between it and between any Windows malware that I've reversed. It should react more or less the same. So with iOS, you only need to have a jailbroken device, and all the Unix scripts that I have in here are cross-platform. They should work without an issue. Yeah, that's all I can say. I do have one last recommendation. If you want to go for iOS analysis, I would recommend Hopper. It's a very good decompiler for Mac O binaries. I believe, I think Mr. Bone had a lecture, not a lecture, but a small page about how to use Hopper. So maybe I'll have a link of it at the end. So yeah, that page was very good introduction to using Hopper. So I highly recommend it. The free version would get you a long way, but the paid version is only $200. So if you work in a company, that shouldn't be a problem. And that's the GitHub repo I mentioned. You guys can go ahead and write it down right now because the presentation will be uploaded to this page right here. And if you want to practice, have any sort of practice with malwares, especially Android and iOS, I highly recommend OASIP's Mobile Security Testing Guide, CrackMe's. They have very good CrackMe's. It's, I believe, 3 Android ones and 2 iOS ones. I'm also thinking of uploading a couple of Android ones. So this is some nice capture the flag events that you can play around with. There is a live malware zoo that is very, very dangerous. It has, I think, over 2,000 malwares you can reverse and play around with as much as you want. And I don't think any of them has write-ups, but there are quite a bit of Android ones. And if you want, you can go ahead and play around with it and make a small write-up. And basically, if you make a write-up, please send it to me on Twitter. I would love to check it out. And that's pretty much it. I really hope this wasn't too long for you guys. Thank you so much.
All right, thank you.
Of course.
You said you had jobs. We'd like to hear about the jobs.
Yes, sir. My company is based in Berlin, Germany, and I was tasked with assembling a team of five strong people that will help me in the cause of fighting fraud, so that we can help advertisers do the best they can. We are hiring junior, mid-level, and senior people for full-time positions. At our company, the idea would be that you would work as a mobile security specialist. That means that you would do a lot of reversing. You would do reports just like the ones that I just did, and you would do a lot of development into our internal security products. If you would like to reach out to me, feel free to go through. My email is in my blog right here. And we have the Twitter account. If you would like to know more about the opportunities, just let me know. And we are accepting junior level people. That means that you don't need to know mobile development knowledge. You only need to have critical brain, and you're not complete asshole. So if you fit the description, you'll get hired.
So you're picky.
A little bit. So yeah. But serious, we are actually hiring quite a bit of people, and there's a lot of positions open, and I believe the team will expand to a team of 10 by 2021. So if you would like to hear more about it, shoot me an email. And thank you so very much, Mr. Bone, for this opportunity. I hope it wasn't too boring for you folks. It's hard for me to get some feedback on your faces, so I don't know if you're smiling, laughing, being sad, or just...
That's the hard thing about teaching online. Does anybody have any questions? Yeah, here's one.
Why does Google let apps install local SDKs? Pop up a box or something that tells you?
I'm sorry, you're gonna have to be a little bit louder. I'm sorry.
Yeah.
I was curious as to why the Google Play Store lets apps install SDKs without notifying the user.
The thing is, Google has nothing to do with this. It's the developer and the developer of the app. So, for example, I used to work in a mobile development agency where we had to install some libraries for image processing. So you can roll your own SDK for image processing. It would take you quite a long time. However, you can use something like, I remember the one I used was called Picasso. It's a very good image processing library, and unfortunately, you don't know what's inside it. If you are a novice developer and you would get a recommendation that, hey, you would get an order, we need to do image processing in our new app, in our new social networking app. And you would need to do this as fast as possible. You don't have time to reverse Picasso's library and actually understand what it's doing. As far as I understood, RxDroider was actually labeled as an SDK, as a library, and as something that would help you have more as an advertisement SDK, something that would basically pop up some pop up some advertisements, and you can use it in your app. As far as I know, they actually did that. However, they did other stuff on the side, and that's where the label malware came in. Why do Google allow that? Well, it's a lot easier to develop applications with pre-made code, pre-made libraries, rather than to roll everything your own. Spotify does not use their own audio processing engine. I know that because there is an office in Spotify in Berlin. I know that. If they did that, I assure you it would take them a lot longer to have the Spotify app ready and a lot more manpower rather than just putting an SDK in there. I hope that answered your question.
Yeah. Okay.
All right. So again, this conversation doesn't have to stop. If you have any questions, just shoot it to me through Twitter. My email is in the link below this blog right here. And I'm on LinkedIn. Just let me know how it goes. And again, thank you so much, Mr. Bone, for this opportunity.
Okay, thank you. I'll put a video up pretty soon. Okay, bye-bye.
Cheers. All right. Cheers. Thank you.
Okay. All right. See if I can. Everyone, his share, is that the end of my share? Let's see. Yeah, that's